So the correlator makes a lot of heat. The correlator must also be kept at a very constant temperature. Around this room are 4 large air handlers. They're not all the same. So Kevin, tell us a little bit about the cooling in this room.
Well, there's 4 large HVAC units. 2 of them on this side of the room have chilled water that's used for cooling the air. The air blows down underneath the floor and then up through the racks. Additional rack fans on the top help pull the air.
So what about these other 2 units?
They do the same job, but they do it a little bit differently. These are called direct exchange units. They have their own compressors and refrigerant in them. They don't rely on the system's chilled water.
I see. Are all 4 running at once, or just now we only have these 2?
Depending on what we need, we can turn on more.
And so those have chilled water, and these ones do not.
Right.
And these ones are currently not operating, is that right?
That's right, they're not on right now, but they can be switched on. They're also controlled by software. So eventually the software will be monitoring the board temperatures. If they can't maintain them from the rack fans, they'll start switching on more HVAC units.
The correlator does not always run in the same mode all the time. And there are some applications, especially those dealing with large numbers of spectral channels and high spectral resolution, that require more computations, therefore producing more heat, therefore needing more cooling.
That's exactly right. You can actually watch the temperature rise on the boards when just a configuration change.
And is it correct yet? Is it correct to say that we have not yet turned this thing on full bore to see its full heat capacity?
Yeah, that's correct.
Yeah. All right. Well, that's a test that we know that we're clearly going to have to do fairly soon.